Hello everyone, welcome to India's largest e-learning platform, Gradeup. How are you all? Is my voice audible to you? Yes or no? Tell me guys, is my voice audible to you? जल्दी से मुझे बताओ, क्या मेरी वॉइस आ रही है? वीडियो सब कुछ सही है आपके लिए? If yes, type the yes. So good evening Sohini. So guys, welcome to next power pack session of network theory, and this session is going to be very useful for you because we are going to learn the unique concepts that are used to that will use to solve you the basic questions of transients. Okay, and after going through this lecture you are going to see the different concepts that you will not find out in any of the book. Okay, or you have to go through different books to learn these type of concepts. So for the transient series, these are going to be very important class, right? So what we are going to learn in this class, so that I will tell you, but what we have learned earlier classes that I want to discuss with you. I told you for the transient, I give you just three things. I just gave you a flow chart. Okay, I gave you the flow chart, I gave you the table, okay, and I gave you the shortcut formula. These three things I gave you in earlier classes, and I told you you can solve the questions using these three things, and 95% question can be solved if you follow the procedure of transient in each and every question. Okay, so good evening Surya. Okay everyone, good evening. So let's call all of your friends. अपने सब friends को बुला लो, आज अच्छी क्लास होने वाली है transient की, बहुत मजा आने वाला है. Okay, so everyone will enjoy today's class. So now I want to discuss those questions which are not going to follow the procedure that we have seen in the last classes. Okay, good evening Komal. Good evening Komal. Okay, so let's start with my introduction. If you are watching me first time, my name is Ishaan Mudgal and I have a 3+ year of experience. I'm 5 times GATE qualified, AMTech gold medalist from NIT Allahabad, and these are my area of expertise. And guys, if you haven't installed the Gradeup app, I advise you to install it, because on a Gradeup app I'm taking a power system free revision classes also, so you can also follow me there. Link is given in a description. And guys, we have also started the new channel especially for the EEE. The name of the channel is Gradeup EEE Impulse. Okay, this is the name of a channel, and right now the classes is also going on there. That, if I'm not wrong, control system revision series is going on in that particular class. So you can also revise the control system and you can complete your GATE course just in 50 days. Okay, and that of free of cost. So you can also subscribe that YouTube channel and see all the videos there. So right now in that particular channel, Rakesh sir and Chandan sir are taking the classes. So I hope you all of are following them also. Okay, yes or no? So tell me, आप लोगों में से कौन-कौन उस चैनल में से अभी वीडियो देख रहा है? Okay, so बताइए बच्चों. So today's class is going to be start with this very beautiful question that I bring to you. So in today's class, I bought 2 or 3 unique question and 2 or 3 previous year question, so that you can know how to utilize the concept of transient in these type of questions. Okay, so first I will discuss with this question. Why I want to discuss with this in this question? What is the unique thing behind this question? Is this particular source. What is the unique thing? I have a dependent source. Okay, if you see the question of transients that has been asked in a previous year, only 2 and 3 times the question that has been asked contain a dependent source. But a dependent source question is very important. Reason why? Because you know, from the 2020 the level of GATE has been increased. Okay, if you see the paper of 19 and 18, the paper level was so much easy, but from 2020 the level has been increased. So you can expect these type of questions from transient also, because transient is always the favorite topic of an examiner. Okay, so this question. Now first of all, you have to check the order of a circuit. Order of a circuit is what? Tell me everyone, what is the order of a circuit? And good evening Prakash, a very good evening. Okay, so tell me the order of a circuit. So right now the order of a circuit is equal to 1, right? Why? Because I have only one capacitor. Okay, now I want to tell you one important point. For every question of transient, whether it is a unique question or the any question, the first step to know the initial value stored in the capacitor and initial current passed through inductor. इस बात को गाढ़ बांध लो कि आपको इनिशियल वैल्यूज पता होनी चाहिए. विदाउट इनिशियल वैल्यू you cannot start the question of a transient. Okay, so here they have already given in question that capacitor in the circuit is initially uncharged. Initially uncharged means initially the capacitor voltage is 0. Okay, now I want to find out voltage V naught T, which is across the capacitor, for T greater than 0. Now to find out the equation of voltage for a general time, I have two methods. First method is to use the shortcut formula. Okay, and the second method is to use the Laplace transformation. Now some people have doubts, sir, when to use when method. So bachcho, always remember to use the shortcut formula, the order must be 1. The order must be 1. And second point, the source must be step signal, or you can say its source must be DC signal, or you can say it must be a step signal at least. And Laplace it can use in any circuit. It can use in any circuit. There is no limitation for the Laplace. So tell me beta, tell me everyone, can we apply the shortcut formula here? Yes or no? Can we apply the shortcut formula here? And guys, like the session. Your like is the attendance. Okay, so I can see that there are more students in the session and there is less like. Okay, so tell me, can we apply the shortcut formula here? Yes or no? Very important point, you must know. Reply करो, reply. जब तक reply नहीं आएगा, interaction नहीं होगा, ना आपको मजा आएगा ना मुझे मजा आएगा. Right? So reply it. Can we apply the shortcut formula here? The answer is no. We cannot apply the shortcut formula. Why? Because you can see the source is the impulse function. The source is the impulse function. For the impulse function, I cannot apply the shortcut formula. Remember this thing. So I have to use the Laplace transform here. Now I told you earlier classes also, whenever you have to change the capacitor into Laplace form, the capacitor will change into a capacitor in series with a voltage source. And the magnitude of voltage source is this. And this is 1 divided by CS. Right? Now you will see initial voltage stored in a capacitor is 0. It means this is equal to 0. And if the magnitude of voltage source is 0, it will act like a short circuit. Basic network. Okay. Now I will draw the Laplace diagram. Now I will draw the Laplace diagram of a circuit. Now see very carefully. What is the Laplace of impulse? Laplace of impulse is 1. So Laplace of 5 del t will be 5. So Laplace of 5 del t will be 5. Okay. Resistor will not change into anything in Laplace or time domain. Resistor remain the same. But the current here will change into a Laplace form, IS, right? Now capacitor. Capacitor usually change in capacitor plus voltage source. But here the initial voltage is 0, so it will act like a short circuit. So the capacitor will just change into a capacitor such that the magnitude is 1 divided by SC. Now C is what? C is 1 farad. Here I have a dependent source. Here I have a dependent source. This is 4 times of IS, right? Right? And finally I have 1 ohm. Now what I want to find out? I want to find out voltage across capacitor V0S in Laplace form. Yes, and once I find out the voltage in Laplace form, by taking an inverse Laplace, I can find out the voltage in time domain. Right? So just see here, IS and 4IS are entering. So how much current will enter here? Obviously 5 times of IS will enter here. Now think about it. The capacitor, think about the capacitor. V0S is equal to what? V0S is equal to 5 times of IS multiplied by 1 by S. So V0S will be equal to 5 times of IS. So it equal to 5 by S IS. This is the first equation. This is the first equation. It means to solve this question, I need to find out the value of IS. Now tell me, how will you find out the value of IS? Everyone tell me. IS की वैल्यू आप कैसे फाइंड करोगे? अगर आपने IS की वैल्यू फाइंड कर ली, V नॉट S की वैल्यू आपके सामने होगी, तो बताओ हाउ विल यू फाइंड आउट द वैल्यू ऑफ IS? I can apply the KVL here. Yes or no? I can apply the KVL in this loop. Remember, you cannot apply the KVL in the loop if the loop contain a current source. But this loop does not contain a current source, so I can apply the KVL here. So if you apply the KVL, bacha, it will be minus 5 plus 2 times of IS plus V naught S. The magnitude of V naught S is 5 by S IS equal to 0. Yes or no? So IS comes out to be 5 divided by 2 plus 5 divided by IS. Now simplify karo usko. So when you simplify it, you will get 2.5 S plus 2.5. Yes or no? 2.5 divided by S plus 2.5. Right? Now there is a two method to to solve this question further. So what is the method? Put this IS here. Put this IS here and you can find out that V naught S is equal to 5 by S multiplied by 2.5 divided by S plus 2.5. Okay, but if you solve this particular inverse Laplace, so it may create the problem. It may create the problem. Whereas if I take the inverse Laplace of current only, then it will be very easier, right? So what I will do, bachcho, I will find the current first. If I find the current first, that will be a Laplace inverse of IS. It means Laplace inverse of 2.5 divided by S plus 2.5. Let me check if I am correct. Yes. So what is the Laplace inverse of this particular equation? I told you in the last class. The Laplace inverse of this is e raised to power minus 2.5t ampere. Okay. But what I need to find out? V naught t. Now think about it. Tell me the formula of capacitor voltage in terms of a capacitor current. What will be the formula of capacitor voltage in terms of a capacitor current? Or you can see here. You can see here very carefully what current is flowing here. Beta, you can see here that capacitor voltage formula. What is the formula of capacitor voltage? 1 by C integration of IT dt. Yes or no? 1 by C integration of capacitor current dt. Yes or no? Now in capacitance given is 1. Capacitance given is 1. Now how much current is flowing through capacitor? IT plus 4IT. See now? How much current is going there? IT plus 4I. So how much current is going here? 5 times of IT dt. Yes or no? Now what is the IT? IT is this particular equation. 2.5 e raised to power minus 2.5t dt. जस्ट अब इसका इंटीग्रेशन कर लो तो कितना आ गया 7.5 एंड ध्यान रखना इंटीग्रेशन कैसे होगा सॉरी नॉट 7.5 12.5 इंटीग्रेशन कहां से कहां तक होगा लिमिट्स बहुत इंपॉर्टेंट है लिमिट्स बहुत इंपॉर्टेंट है ओके कहां से कहां तक 0 से t so when you integrate this one you will get e raised to power minus 2.5t 0 से t divide by 2.5 or I will get 5 minus 2.5 5 1 minus e raised to power minus 2.5t. So this is the answer of capacitor voltage. Okay, and this question is very much simple because whenever they will give you the Laplace question, the circuit will be easier. You can see the circuit is so much easier. So whenever they will give you the Laplace question, the circuit will be so much easier. If they give you the step signal or DC signal, then the circuit become somewhat tricky or complex. Any doubt in this question? Anyone? And guys, I'm sharing the PDF of this file in a Telegram group. So if you haven't joined the Telegram group, I advise you to join it so that you can get a PDF file there. Okay, just after the class, I will upload the PDF file on a Telegram group. Okay, so I hope none of you have any doubt. Good. Okay, now next question. Next question. Now very beautiful question, beta. This is a very beautiful question. Many concepts we will learn from this question. Okay, very beautiful question. Read the question carefully. Read the question carefully and tell me what is the first thing you think about this question. You have to tell me the order of this question first. You have to tell me the order of this question. What is the order of this question? Everyone, whenever you solve the question of transient, first of all you have to identify the order of a network. Okay, and बताओ अच्छे क्वेश्चन है, लास्ट का क्वेश्चन अच्छा लगा आप लोगों को, yes or no? The last question, did you like the question? Okay, so let's see. The order of this network is 2. Why order is 2? Because I have a 2 capacitor which are charged with a different voltage initially. Okay, you can see across the capacitor 1, initial voltage is 2 volt. Across the capacitor 2, initial voltage is 1 volt. It means C1 and C2 are charged initially with a different amount of voltage. Okay, so the order is 2. I have a resistor of 1 ohm, C1 is 1 farad, C2 is 1 by 2 farad. At t equal to 0, the switch K is closed. Find IT for all time t. Find IT for all time t. Okay. So सूर्या बेटा टेलीग्राम चैनल का लिंक ना आपको डिस्क्रिप्शन में मिल जाएगा. Okay. Name same ही है, Gradeup GATE21 Okay. You can find out the link in the description below. Okay बेटा, so चलो solve this question. Now second order question, always remember for second order question, always remember for second order questions, we have to use the Laplace transform. We have to use the Laplace transform. If I want to find out current equation, like in this question, I want to find out the IT, so I have to use the Laplace equation. Okay, now in Laplace what happened? Capacitor change into a voltage source in series with a capacitance like this, 1 divided by S C1. What is the magnitude of C1? It is 1. Okay, and what is the initial voltage stored in the first capacitor? It is 2 volt, so it comes out to be 2 by S, right? I have a resistor in series which has a value of 1 ohm, and finally I have a capacitor here, and here I have a voltage. Okay, fine, and the value here is 2 by S and the value here is 1 by S. Now think about one point. Now I will tell you one logical way to solve this question. Okay, I will tell you one logical way to solve this question. Okay, Sai Prakash, you can see the Telegram link in the description below. So after the class, just go to the link and you will join the session. You will join the Telegram channel. Now beta, listen very carefully. This question is very beautiful. Okay, let's suppose I have two capacitor 1 and capacitor 2. Okay, this capacitor is highly charged. So let us suppose I am place this capacitor above than the capacitor 2 because it is a more charged than capacitor 2. As soon as the switch will close, when you switch on the particular network, means when you close this particular switch, so what happened? Because of the voltage difference between two capacitors, we have a voltage difference. Because of the voltage difference between two capacitors, the C1 will start to discharge and C2 will start to charge. So it is discharging, it is charging. Okay, now when discharging and charging will happen, the current will flow. So at that time will come when the voltage across them becomes same, right? At that time will come, the voltage will become same, and at that time voltage across both the capacitor become equal. Now when the voltage across both the capacitor become equal, there will be no potential difference and the current will be 0. Okay, so what I told you, when capacitor C1 is charged more than the C2, the current will flow from C1 to C2, but the current will flow till both the capacitor C1 and C2 are not charged equally. When C1 is discharged to a particular voltage V and when C2 is charged to a particular voltage V, then the current will go into stop, or you can say there will be no flow of a charge there. So here one formula you need to remember very carefully. What is the voltage at t tends to infinity? See, the voltage at t tends to infinity is C1 V10 plus C2 V20 divided by C1 plus C2. This formula is come from the conservation of charge principle. This formula is according to the conservation of charge principle. See what happened? Initially capacitor C1 is charged, it is about to discharge, and C2 is about to charge. Okay, so it is discharging, it is charging. Now a voltage will reach where both of them will equal, and at this voltage what happen, the current will stop because there is no potential difference now, and this thing happen only at a steady state. That's why I have written voltage at a steady state. So voltage, this question has been asked earlier in the GATE exam. That's why I'm going to tell you. Voltage at steady state when two charged capacitors are connected by a switch, it will be equal to C1 V10 plus C2 V20 divided by C1 plus C2, where V10, V20 are the initial voltage stored in the capacitor. Fine. And you can see both of them become parallel. So this voltage VC1 infinity will be equal to VC2 infinity is equal to V infinity. Means at steady state, the voltage across both the capacitor become equal and the flow of charge will stop. Okay. But right now I want to find out the current. So what happened? When you find out the current, you will see the current IS will flow in this direction. Why the current will flow in this direction? Because C1 is more charged than C2. So C1 must discharge. So current will flow in this direction. So can I find out the equation of current? Simple है ना? क्या होगा? Total voltage 2 by S minus 1 by S divided by 1 plus 2 by S plus 1 by S. This will be the equation of current. Yes or no? Equation of current क्या होती है? Higher potential minus lower potential divided by the impedance of a path. So this is a higher potential minus lower potential divided by the impedance of a path. Okay. So from here, IS comes out to be what? 1 by S, or you can say multiply by S plus 3, right? And here you can see 1 divided by S plus 3. The current IS comes out to be 1 divided by S plus 3, right? Any doubt here? Now IT will be Laplace inverse of IS. So Laplace inverse of 1 upon S plus 3 will be e raised to power minus 3t ampere. So this much amount of current will flow from this particular point IT. Any doubt here? Anyone? Ask me. If you have any doubt, you can ask. Now I want to find out in second part, I want to find out V1t for t greater than 0. Okay. Now what is the V1t? V1t is voltage across capacitor 1. Now this whole is the V1t. This whole is the V1t that I am going to represent as V1s. Okay. So what is V1s? You can apply the KVL here. If you apply the KVL here, you will see V1s is equal to, see, apply the KVL here. You will see V1s is equal to minus IS multiplied by S plus 2 by S. So what is IS? So what is IS? IS is 1 upon S plus 3. So it comes out 1 minus S divided by S plus 3. Okay. It will come out 2 by S minus. Now apply the partial fraction here. Apply the partial fraction here. So when you apply the partial fraction, you can write this like this. 1 by 3. Okay. Now after that, just I have to solve that. Now after that, I just have to take the inverse Laplace. Okay, beta. So inverse Laplace, now you should remember the Laplace of few points. So when you take the inverse Laplace of this one, so V1t will come out what? V1t will come out 2 minus 1 by 3 plus 1 by 3 e raised to power minus 3t. So 3 to the 6 minus 1, 5 by 3. It will be 5 plus e raised to power minus 3t divided by 3. Okay, this will be the inverse Laplace. So let me check the calculation once. Bacha. Yeah, correct. Okay. So few inverse Laplace I want to discuss with you that you should remember for the network. For example, Laplace inverse of k divided by s plus a. Laplace inverse of k divided by s plus a is k e raised to power minus at. Similarly, Laplace inverse of k divided by s will be equal to k times of ut. Laplace inverse of 1 divided by s raised to power n. Can anyone tell me the Laplace inverse of this one? Can anyone tell me the Laplace inverse of this one? Or Laplace inverse of s divided by s square plus a square is equal to cos at, and Laplace inverse of a divided by s square plus a square is equal to sine 80. So this common Laplace inverse you should remember. This will help in your network. Apart from this, there will be no Laplace inverse that will come in your networks. Okay. So tell me anyone, Laplace inverse of 1 divided by Sn. बहुत जरूरी है, बहुत जरूरी है. You know that Laplace of t raised to power n is equal to 1 divided by s n plus 1 and factorial. Yes or no? This is the Laplace. So when you take the Laplace inverse, so what happens? It comes out to be t raised to power n minus 1 divided by n minus 1 factorial. Okay. Okay. So Laplace and Laplace inverse are very very important guys. Fine. चलो अब नेक्स्ट क्वेश्चन सॉल्व करते हैं एंड इस क्वेश्चन के बाद मैं आपको एक और ब्यूटीफुल क्वेश्चन बताने वाला हूं. ठीक है. तो सबसे पहले ये वाला क्वेश्चन देखते हैं. यू कैन सी द क्वेश्चन इज फ्रॉम द GATE EE 2019 and it is of 2 mark question, and this question was very very easy that this question did not 2 marks के लिए तो ये है ही नहीं. This question is just for the 1 mark, but you can see a GATE has been asked this question for a 2 marks because they want you to remember one thing for this question. What is that thing? What is the question here? A 0.1 microfarad capacitor charged to 100 volt, okay, is discharged through a 1 kilo ohm resistor. See what is given. I have a capacitor which is connected to a resistor, okay, like this. Now initially this capacitor is charged to 100 volt. Initially this capacitor is charged to 100 volt, and when I will close the switch, at that position capacitor will discharge through resistor. The resistor value is 1 kilo ohm and here the capacitance is 0.1 microfarad. Now beta, I will tell you one small equation that you need to remember. ठीक है. Whenever a capacitor discharge, you need to remember that capacitor voltage is equal to V e raised to power minus t by tau. Remember this equation because on this RC circuit many times a question has been asked. Okay, so this is the source free circuit. Why this is a source free circuit? Because you can see there is no source connected to a circuit. The capacitor is charged initially, so all the energy which is flowing in this circuit is because of a charged capacitor. And if you think about a steady state, when this system reached the steady state, at that point capacitor will be fully discharged. Yes or no? If I talk about at steady state, what happened at steady state? At steady state capacitor voltage will be 0 because it will be fully discharged and there is no source that will charge the capacitor. Okay, now these things will be represented by this equation. Right guys. So now what is the capacitor voltage for this equation? V is initial voltage which is 100. V is initial voltage which is 100. E raised to power minus t by tau. Now tau is the time constant is equal to RC. R is 10 raised to power 3. C is 0.1 10 raised to power minus 6. Okay, so let me see what happened. 10 raised to power minus 4 second. So I can write it comes out to be 100 e raised to power minus 10 raised to power 40 volt. Yes or no? This is the capacitor voltage. Now read the question again. They are asking the time in millisecond required for the voltage across the capacitor to drop to 1 volt. It means now they are saying the capacitor voltage is equal to 1 volt. So here I can write 100 e raised to power minus 10 raised to power 40 is equal to 1. E raised to power minus 10 raised to power 40 is equal to 0.01. 1 divided by 100. Now if I take ln both side, if I take natural log both side, so what is ln of 0.01? Let me see. Let me calculate very quickly. What is ln of 0.01? It comes out to be minus 10 raised to power 40. It comes out to be minus 4.61. Okay, now time comes out to be 4.61 divided by 10 raised to power 4. Now they are asking the time must be in millisecond. So for the millisecond, it comes out to be 0.461 millisecond. Simple question. Simple question. Just the logic that you want to understand in this question is that when the capacitor discharge, the equation it follows will be this one. Okay, and when the capacitor is charging, then the equation that a capacitor follow is this one. This is the equation of charging. And remember, at that time this is a source voltage, because in the time of charging initially the capacitor will not be charged, right? And this is the source voltage. Fine. Any doubt in this question? Anyone? Any doubt in this question? So now I want to discuss with you one of the most beautiful question in a transient. Let me add 1 or 2 pages. Okay, now I will discuss with you one of the most important question, beautiful question in case of a transient. Question is, see very carefully. This is capacitor C1, this is capacitor C2. Now capacitor C1 initially charged to voltage V1 and capacitor C2 is initially charged to V2 such that V1 is greater than V2. This is given. All of these things are given in this circuit. Now find what I need to find out. First of all, find equation of current. First I need to find out equation of current. Not equation. We will not talk about equation. The waveform of a current or a type of current. So in the first case, I want to find out the type of current. Type of current means options are: first one, impulse; second, it will be step function; third, it will be DC function; and fourth, the function is 0. Okay, so in the first part of this question, I need to find out the type of current. Now use your mind. And tell me. Everyone use your mind and tell me what will be the answer for this question. The switch is closing at t equal to 0. Everyone think about it. I want answer as well as some brief explanation. Okay, so the option are the type of current will flow here, IT. What type of current will flow? Is it a impulse, step, DC function, or it will be a 0? Or instead of 0, remove the 0, just type exponential. Instead of 0, I will take another option which is exponential. Okay. Now, bacho, tell me. Everyone, reply guys. Tell me what will be the answer and why. Brief introduction or brief reason you will give me. What will be the type of current here? To see solution. So I will give you the solution two way. One is the conceptual way, one is the logical way. So think about logically. The capacitor C1 is charged at a higher voltage and capacitor C2 is charged at a lower voltage. Okay. Now as soon as you close the switch, what happens? C1 is at higher potential, C2 is at lower potential. So the current will flow. But there is no resistor in this circuit. You will see there is no resistor in this circuit. So what happens? The charging and discharging time will be done instantaneously. What happens? C1 will discharge to a voltage, to a particular voltage, and C2 will charge to that particular voltage instantaneously, because there is no resistor in the circuit. Whenever the time lag is come for charging and discharging, that is only because of a resistor in a circuit. So in this particular network, there is no circuit. So the capacitor C1 and C2 will discharge and charge respectively in less amount of time, or you can say in just a less amount of time. Instantaneously your capacitor C1 will discharge and C2 will charge. So the current which is flowing here will be the impulse. Exponential current will always come when you have a resistor. Okay. Now why not the DC function? Because a DC current will look like this one. But think about it. After DC function, or you can say step function. DC and step, actually these both are the same option. So instead of DC, I am giving a 0. So IT, which is a step function. Okay. Now, according to a step function gives me the knowledge that current will flow always. But I told you, as soon as the voltage across C1 and C2 become equal, the potential difference will be zero. And at that time, what happen? There will be a no flow of current after that, because potential difference is zero, right? So what happen when capacitor voltage become equal to the capacitor voltage 2, then current will be zero. And how much time it will take to make the voltage equal? That time will be instantaneously. Why? Because there is no resistor there. So the current which will be flow will be the impulse current. So the current which will flow here is the impulse current, like this, right? Like this. After that, there is no flow of current because the voltage become equal. Okay. Now the voltage become equal. Now if I want to find out mathematically, if I want to find this mathematically, so what I will do, I will change the capacitor into a Laplace form. So change a capacitor into a Laplace form like this. This become 1 divided by S C1. This become V1 divided by S. This become V2 by S. This become 1 divided by S C2. And the current is flowing here, IS. So what will be IS here? IS will be V1 by S minus V2 by S divided by 1 divided by SC1 divided by 1 divided by SC2. Okay. You will get V1 minus V2, V1 minus V2, C1 C2 divided by C1 plus C2. Yes or no? When you solve this particular equation, you will get this type of value. Now IT is the Laplace inverse of this particular quantity, which is V1 minus V2 divided by C1 plus C2 multiply C1 C2. Now bacha, think there is no S quantity. You will see there is not any variable S in this equation. It means this is a constant, and Laplace inverse of a constant, Laplace inverse of a constant term is nothing but delta, which means impulse function. So you will see the current equation which come out is the impulse function delta t. Impulse function delta t. So this is the equation of current, and from there also you can see what is the nature of a current. The nature of current is impulse. Nature of current is impulse. Any doubt here? Anyone? कोई भी doubt हो बच्चा पूछ लेना. Any doubt? If you have any doubt here, you can ask right now. Okay, fine. Now second part of this question. Second part of this question is that. Second part B. Draw waveform of V1t and V2t, where V1 and V2 are the voltage across the capacitor C1 and C2. तो अब मुझे इन दोनों के across की waveform बनानी है, voltage waveform. Now think about it. Before the switching, the particular capacitor, this is VC1, VC2. Okay. Now before the switching, capacitor C1 was charged to a voltage V1. Yes or no? Before the C1, capacitor is charged to a voltage V1. Okay, and this is I am drawing for the capacitor T. Now instantaneously what happened? The capacitor is discharged to a final value because the current which is flowing is just an instantaneous current. So what happened here? It will goes down here. Okay, and after that it will remain here forever unless until or koi switching na ho, it will remain here forever. Similarly, and this voltage let us suppose is V. Similarly, what happened to capacitor C2? Before t equal to 0, it was, let us suppose, charged to V2. Now instantaneously it will charge more because C1 is discharging, and again the final voltage will be V, because when voltage across both the capacitor become equal, the current will be 0. Now what will be the magnitude of voltage V here? I told you the formula earlier. The voltage is CV10 plus C2V20 divided by V1 plus V2. The same formula that we have seen just a few minutes ago. So remember, this is a very powerful formula and many questions have been asked on your exam based on this formula. Okay, now listen very carefully when to use this formula. Okay, whenever you have given a network such that it contain only capacitor, then this will give you voltage at every time instant. This will give you voltage at every time instant if a network contain only two capacitor without a resistor. But when a network contains two capacitor with resistor, then this voltage will be given only at t tends to infinity, or I can say steady state. Okay, but for this circuit, you know, it will reach infinity just in an instant. So I can use this formula everywhere or at every time instant. For example, if they're asking you what is the voltage at 3 seconds, so answer will be V. If they're asking you what is the voltage across capacitor 2 at 10 seconds, again the answer is V. But when you have a resistor in the network, then this formula is only applicable for t tends to infinity. Okay guys, any doubt here? Anyone? Ask me. If you have any doubt in this question, ask me. Okay, and I want everyone to ask some questions. Okay, no one is asking question, but yeah, Surya and Upendra has given the answer to an earlier question. So beta, so I hope now you got it. The answer is not step, the answer is impulse. And why the answer is impulse? Because it will take an instantaneous time to discharge a capacitor C1 and to charge a capacitor C2. Fine. Okay. Next question. Next question. Now see this question. Now you have to do this question in your homework. So let not give the question homework, because मैं आपको homework में question देता हूँ, आप solve करते नहीं हो, तो इससे अच्छा मैं यहाँ पर solve करा दूँ. So let's do this question right now. Let's do this question right now. So you can see here, this is the GATE Instrumentation Exam 2019 and 1 mark question. What is given question? In the circuit shown below, initially switch S1 is open. The capacitor C1 has a charge of 6 coulomb. The capacitor C1 has a charge of 6 coulomb and the capacitor C2 has a charge of 0 coulomb. So I know that the voltage across the capacitor is equal to charge divided by capacitance. Yes or no? This particular equation I know, right? So voltage, initial voltage across capacitor C1 will be the charge it has 6 coulomb divided by the capacitance, which is 1, equal to 6 volt. Similarly, capacitor voltage initially across C2 is how much? Charge is 0, so it will be 0. It means C1 is initially charged to 6 volt, C2 is not charged to any voltage. Now as soon as you switch, this particular switch will close, the current will start to flow. The current will start to flow, right? Now they are asking what will be the charge on capacitor C2 in steady state. Now remember, I gave you one very powerful formula that voltage at infinity will be what? It will be C1 V1 plus C2 V2 divided by C1 plus C2. Yes or no? They are asking at a steady state, so I can use this formula directly, right? So what is capacitor C1? It is 1. What is the initial voltage across the C1? It is 6. Plus capacitor C2 is 2. Initial voltage is how much? It is 0. Divide by C1 plus C2. So when you solve this question, it comes out to be 2 volt. Means at t tends to infinity, the voltage comes out to be 2 volt. But what I need to find out? I need to find out the charge on C2. So what is the formula of charge? Voltage multiplied by capacitance. So voltage is 2 volt, capacitance is 2 farad. Give you 4 coulomb. So this much charge will come across the capacitor C2. Now, if you don't know this formula, then what happen? You have to find out the equation of voltage. Then you have to do the inverse Laplace. You have to do the Laplace transform, and the question will consume much time, and even the questions just of 1 mark. Okay, and if you do this much calculation 1 mark question, then you are not justifying with the 2 mark questions, right? So this formula is very powerful. Like this on this formula, many questions have been asked on different branch, IN, EC and EE. Okay, fine. No Ram, the answer is not 12. So I hope you understand this problem. Now next question. Next question is GATE EC1 2017, 2 marks. You can see GATE EC1 2017 2 marks. Again, question is very beautiful. Question is very beautiful. Just I need to use my mind to solve the question. Okay. So to solve the question, one thing you should know. One thing you should know, bacha, that if I have an RL circuit, if I have the RL circuit such that here I have a switch, voltage V, R, L, and the switch is closing at t equal to 0. Then current equation of current IT is equal to V by R e raised to power minus t by tau. This is the equation of current. Okay, this is the equation of current. Am I right? Am I right? No, I'm not right. Sorry, this is not the equation of current. Let me check it once. Yeah, this is the equation of current. This is the equation of current when a switch is closed at t equal to 0 and the current will flow. Now, how can I find this equation of current? This particular will be find using the shortcut formula. But it will be very helpful for you if you remember this formula. Why? Because many question has been asked on RL circuit. So this question is also based on this type of a circuit, but few things has been changed. If I ask you what is the order of a circuit, can you tell me what is the order of this circuit? Yes or no? Can you tell me the order of this circuit? Everyone, I need answer. Order of this particular circuit, is the order 1 or 2? Is the order 1 or 2? So the order of this circuit is 1. Why the order is 1? Because these two inductors are parallel and I can combine these two inductors. That's why the order of this circuit is 1. Remember this point. When you combine the energy storage element, the order will get reduced. So the order for this circuit is 1. This you are asking, beta. In this, the denominator is C1 plus C2. Denominator is C1 plus C2. So it will be 1 plus 2, 3. Okay. Fine. Now here you can see. Now this is a inductor. Now I need to find out I. Okay. So what can I do? If I able to find out I dash, if I am able to find out I dash, then I can apply the current division rule. So what I will do? First of all, I will write the equivalent diagram. What is the equivalent diagram? This is I will combine these two inductors. So if I combine these two inductors, the parallel combination will give me 2 by 3 Henry. The parallel combination of these two inductors gives me 2 by 3 Henry. And here I have a voltage source such that at t less than 0, it is 0. At t greater than 0, it is 15 volt. Okay, it is 15 volt. Hello, Polly. Okay, so first I will find out the current I dash here. If I am able to find out the current I dash, then I can use the current division rule to find out I. Okay, okay, yes or no? So what will be the I dash here? So I dash will be, I will use this formula. I will use this formula. Formula is V by R 1 minus e raised to power minus t by tau. Now what is voltage? Voltage here is 15 volt. Resistance is 1 minus e raised to power minus t by tau. Tau is L by R. So tau comes out to be 2 by 3, right? So it comes out to be 3t by 2, right? This is the I dash t. Now if I know the I dash t, then I should find out I. What will be the I? Apply the current division rule. I dash t multiply by 1 divide by 1 plus 2. Yes or no? Current division rule pata hai na? In inductor, current division rule will be applied similar to the resistor. So I dash t is 15 1 minus e raised to power minus 1.5 t divide by 3. So it comes out to be 5 1 minus e raised to power minus 1.5 t. Yes or no? This is the equation of current I. Now what is asking in a question? At what time in second the current I in the circuit will reach the value 2 ampere. So just put this equation equal to 2 ampere. So I is equal to 2 ampere. It means 5 1 minus e minus 1.5 t is equal to 2 ampere. Yes or no? Right? So 1 minus e raised to power minus 5t is equal to 0.4. E raised to power minus 5.2 comes out to be 0.6. And when you solve this question by taking natural log both sides, you will get 0.34 second. Okay, you will get 0.34 second. Yes, correct, Sohini. Correct answer. Okay, bacha. So let's see. Again, I am going to tell you one important point. This is a order 1. Okay, now listen one point very carefully. If these two inductors have been charged with some different value of current, okay, then that will be a order 2. For example, let's take, I am taking two capacitor in series, okay, but I am saying initially the voltage across this capacitor is 2 volt and initially the voltage across this capacitor is 4 volt. Okay, so again you cannot combine these two capacitors. Remember this point, you cannot combine these two capacitors, and here the order will be 2. This is very important. Need to remember, if two capacitors are connected in series but they have differently charged, so you cannot combine these two capacitors and make it a one capacitor. In that case, it become order 2. And same thing happen for inductor also. Okay, guys. Okay. Now this is your homework question. This is your homework question. Although this question is your gate question, but don't see any reference book for this question. I want answer for this question. Everyone should give me an answer in a comment section. Okay. After solving this question, hit the comment section and you have to give me the answer. Okay. Now, if you have any doubt, you can ask. Otherwise, we will end the session. And bacha, next class is on Monday. Okay. Next class is on Monday, and everyone should also join our new channel that we have launched, especially for the EE and ECE students. The name of our channel is Gradeup Impulse ECE. And you will see on that particular channel, Chandan Sir and Rakesh Sir is taking a classes of control as well as the communication and I guess analog also. So you can also watch those classes so that in minimum amount of time you can cover the syllabus. Okay, revise it. Okay, 50 days बचे हैं, means not 50 days कितना टाइम बचा है आप लोगों को पता होगा, 1 month 2 month बचे हुए. इन 2 month में आपको अच्छे से पूरा सिलेबस रिवाइज करना है, अच्छी रैंक को स्कोर करना है. ओके, अगर आप जिद करोगे तो आप पक्का अच्छी रैंक को स्कोर कर पाओगे. Okay, so if you are determined enough, you can score it well. Otherwise, what happen? If you are not determined, then why you are studying? Just leave the study. Okay, so whatever you do it with a full determination and full concentration. Okay, and guys, again, I am taking a power system revision series also, 6 p.m. to 7 p.m. Power system revision series from the 1:30 p.m. to 2:30 p.m. daily on a Gradeup app. So you can also follow me there, so you can revise your power system also. Okay, and right now we are doing the fault analysis there. Okay guys, so we will meet you on Monday, and on Monday I will bring you two-port network. So till then, enjoy it. पढ़ाई करना, छुट्टी दे रहा हूँ इसका मतलब ये नहीं कि आप लोग मजे करोगे. पढ़ाई करो, अच्छे से रिवाइज करो. गेट एग्जाम is just a few months ahead. Okay, so take care. Bye bye. I hope you like the session. Okay, take care. Good night.